This is section 1.5 on induction and polar covalent bonds. So what we're going to be talking about in this section is how the electronegativity of atoms influences the nature of the chemical bond between them. So in table 1.1 in your book, there is a nice little chart showing how electronegativity increases as you go to the right and from bottom to top in the periodic table. If the electronegativity difference between two bonded atoms is small, 0 or 0.5, for instance, or between 0 and 0.5, then we would call that bond covalent, meaning the electron pair is shared pretty well between the two, and there isn't very much induction that happens. Induction is you could imagine it, the unequal sharing of a bond that results in a partial positive and partial negative charge on either side of the bond. If the bond is around 1, between 0.5 and 1.7, we call this bond a polar covalent bond, and there's a significant dipole that is introduced on the two atoms just by nature of electronegativity differences. To show this, we can look here at my tablet. There we are. And we can look at the bond between carbon and oxygen, like this. Okay, so in this bond, the electronegativity of carbon is 2.5. And the electronegativity of oxygen is 3.5, which is a difference of 1. And that means that there will be a significant dipole that develops because of this. It will start at the carbon and go to the oxygen. That's the direction of flow of the electrons, which means that the carbon will have a substantial partial positive charge and the oxygen will have substantial partial negative charge. This is going to influence how this bond reacts whenever we are looking at its chemistry. Now, we can have an even larger disparity in electronegativity, such as between sodium and chlorine in common table salt, because if you remember from general chemistry, sodium has a full positive charge, chloride has a full negative charge because it's ionic bonding, and it's ionic because the electronegativity of sodium is 0.9 and of chlorine is 3. That's 2.1 difference. And that tells you that certainly there's a full charge on both atoms. In organic chemistry, in this course specifically, we're going to talk a lot about how dipoles change the reactivity and properties of a molecule and of bonds between atoms. So please keep a lookout in your mind for these electronegativity differences because we'll be talking about them a lot. And that is section 1.5.